we'll be studying about intelligent tutoring system using means and analysis. This has been done by R. Sriram and A. Kirtana. First of all, we will get to know about what's means and analysis. So we have studied different strategies which can reason either in forward or backward direction. So to solve a specific problem, we have studied forward technique and backward technique. But a mixture of both technique is appropriate for solving a complex and large problem. And Such a method is known as means and analysis, where it uses both forward and backward technique to solve a complex problem. Here, first it solves the major part of the problem and then goes back and solves the smaller parts of the problem, which arrive during combining the big parts of the problem. So the means and analysis was introduced in 1961 by Alan Newell and Herbert A. Simon in their problem solving computer program, which was named as General Problem Solver. So the MEA analysis process is centered on the evaluation of the differences between the current state and goal state. So at every step of the problem solving, it will keep on evaluating the differences between the current state and goal state to solve the problem. So how does this means and analysis work? So there are for some steps to to be followed while applying means and analysis on a specific problem. Step 1 is measure the current state of the things by doing as is the study and capture the status at a macro level and to a possible micro level. Step 2, capture the deficiency in the current state and avenues for improvements and define the goal state. Define the to be state or goal state at a macro level and to a possible micro level. Step 3, compare the current state and goal state, and if there are at the same level, the problem is resolved. Step 4, list the differences between the current state and the goal state at macro and micro levels. Step 5, convert the differences into deletions slash modifications to current state and new additions. Step 6, define the action to implement the changes as defined in step 5. Step 7, implement the changes and measure the actual result with the planned goals. Step 8, do course correction and achieve the final goal. So this can be explained clearly through an example. So for example, here we can see that the initial and goal state are given as follows. In this problem, we need to get the goal state by finding differences between the initial state and the goal state and applying certain operations. So this is the initial state and this is the goal state. So in the initial state we can see that a circle is there inside which we can see a square, and outside the circle there is a dot. And in the goal state we have to get a circle and a square outside the circle with a bigger size. So to solve the problem, we will first find the differences between initial and goal state, and for each difference we will generate a new state and will apply the operation. The operators we have for this problem are move, delete and expand. So first we'll evaluate the initial state. In the first step we'll evaluate the initial state and we'll compare the initial and the goal state to find the differences between both states. So this is the initial state. Then we'll be applying a delete operation. As we can see from the differences from the first step, that there is no dot in the goal state, and to remove that we'll be applying delete operation. So then we'll get, after applying delete operation, we'll remove the dot. Then in the third step we'll apply move operator. So here we will be basically moving the square which is inside the circle outside the circle. So for this we will be using move operator to move the square. Hence we have moved the square. Now By apply, we have to apply expand operator, because comparing the initial and the goal state, we can see the square is slightly bigger in the goal state compared to the initial state. So now we will be applying the expand operator on the square, so it will finally reach our goal state. This means using this means and analysis, we will now design a intelligent tutoring system.
Want to unlock personalized learning? This intelligent tutoring system uses AI powered by means analysis to analyze your strengths and weaknesses, then guides you with step by step problem solving tailored just for you. Imagine learning that feels like it was made exactly for your needs, leading to deeper understanding, stronger problem solving skills, and ultimately improved learning outcomes. The system combines your knowledge base packed with domain expertise with a student model that tracks your progress, knowledge level, and even your learning style. The system then uses a problem solving engine to pick the perfect challenge and guide you through it step by step using MEA. Finally, a user friendly interface lets you interact, ask questions, and receive feedback, making learning truly personalized. So, let us see the MEA cycle in an ITS. First, the system gives you a problem that's just right for your learning level, and then it watches you try to solve it. If you seem stuck, it knows to help. If you are stuck, no worries. It might give you a little hint or show you different ways to approach the problem. Once you try again, the system gives you feedback on your answer, like a high five for getting it right or a helping hand if you need more practice. At the end, you'll have a solid understanding of the concept. So this is the ME cycle in action, making sure your learning process is personalized and you get the support you need to succeed. Now, let us see an example to understand this system better. The scenario is a student called Sarah, a 9th grader working on geometry. Basically, the problem is to find the area of the kite, where the base and height of the kite is already given. First, the system will monitor and then reflect. It will ask Sarah to enter the formula of the area of a triangle. If the entered formula is correct, it will move on to next step. If the entered formula is incorrect, it will provide a hint. And then it will ask Sarah to draw a diagram of the kite to represent the height and base. And then it will ask her to apply the value of base and height into the area formula. If the calculations provided by Sarah is correct, it will provide a positive feedback. If the answer is incorrect, it will check the calculations and provide the needed guidance. Finally, it offers related practice problems or asks her
let
to
us see the
reflect on her
benefits
learning
of
process.
MEA approach.
Firstly, personalized guidance is a key feature. Sarah with MEA receives tailored prompts and feedback based on her individual understanding, ensuring she stays engaged and on track. Secondly, MEA promotes active learning. Instead of passively receiving information, Sarah is encouraged to reflect, explore, and apply her knowledge independently before receiving feedback. This hands-on approach not only solidifies her understanding but also fosters a deeper level of engagement with the material. Lastly, MEA nurtures metacognitive skills. Through the ITS prompts, Sarah is prompted to think about her own thinking process, developing her ability to solve problems independently in the future. Lastly, MEA nurtures metacognitive skills. Through the ITS prompts, Sarah is prompted to think about her own thinking process, developing her ability to solve problems independently in the future. This metacognitive awareness empowers her to become a more self-directed learner. In conclusion, the MEA approach offers a personalized, active, and metacognitive learning experience. By tailoring guidance, promoting active engagement, and fostering metacognitive skills, it equips learners like Sarah with the tools they need to thrive academically and beyond. So this is all about intelligent tutoring system using means and analysis. So yeah, that's it. Thank you.